Alright then. Alright, I've clicked the button. Hopefully now this is the beginning. Hello? Okay, well it seems... Oh, of course, and it clipped before I actually started the stream. Okay, great. Alright, well, I'll wait for everyone to get in, but it looks like it is working. Anybody still in chat right now? Interesting. Right, well, I will set up chat on my phone then. My gosh, there's a ridiculous amount of delay on the stream. Wow. Let's see. "41 seconds, holy crap." Alright then. Oh, looks like we have some people now. There are people in the chat. Hello there. Well, it's not happy that my stream rate isn't, or my bit rate isn't too high, but that shouldn't matter. Right then, well, I guess I'll start showing off what I have so far with AI Sandbox. So, right now, it is, yeah, temporary graphics, of course, because, holy crap, I have no idea how to make stuff look pretty. This is using Java, first of all. It is using Java JDK 8, which is ancient. We're now on 18. And this is only because my teacher at school used Java 18 to be able to package JavaFX, which is this visualization part of Java that allows us to do fancy windows like this really easily. Java 8 was the last one that actually had that bundled within it. So this is the old version of AI Sandbox. We can just launch it within the new version, which is nice. Put down a bunch of markers and watch it struggle horribly. I guess there's no reason for it to curve there. Yeah, it's not really going to do all too well. So this old algorithm used just simply a Darwinism genetic algorithm, and the fitness is an absolute you get it or you don't. It's nothing to do with how close the point is to actually being correctly classified. So the rate at which it learns is very slow because it has to get it completely right, otherwise it doesn't make any progress. And so if we exit out of that and then come back to main menu and go into decision space, now we have save files, which is nice. So we can load up, and I've got a whole bunch of things. So this was the thumbnail that you've seen. Modern art, yeah, that seems to be mostly what we can see created from this thing. It's not, it doesn't really look like anything, but I have made one nice thing. He's a happy boy. I tried to get a smiley face. This didn't actually take that long. It took 4,000 generations to get a simple curve in the old one, but this only took 900, so it's going a lot faster, which is nice. Let's see, what else do I have? Dum-Dum, right. So this was me trying to test out... there was this one bug where it would just randomly crash for no reason, because I don't know. Yeah, JavaFX was being weird, because I've made this multi-threaded, actually. I've made it multi-threaded so that the training goes a lot faster. So all the training and stuff is on one thread, and then the main thread is JavaFX, so keeping all this display stuff alive. And turns out JavaFX really doesn't like it when you touch its variables while it's working. So every once in a while, it'll just crash for no reason. So I just let this thing run for 18,000 generations, and it didn't get really far, but fortunately, I fixed the bug. I was still drawing on the main the training thread. I had to switch that over to the main thread, but yeah, that should be fixed now. And then we've just got one more modern art guy right here. Wonderful. Alright, let's see. Do we have more people? Not quite. No one yet. I see there's at least one person in the chat. Is that the 0PSS guy? Or is that Cubic? If you're there, let me know. I don't want to be talking to the endless void. I do have the chat set up on my phone, so hopefully I can monitor it while I'm actually doing stuff. Yeah, if we want to create a new brain, all we have to do is specify a name. So stream, why not? We can choose how many layers we have in the neural network. We'll just do one for now, and then we can choose how many nodes we have within those hidden layers. So right, the layer count is how many hidden layers there are. You can't have 0, but then it's the same thing as Dum-Dum there. It can't curve the lines, unfortunately, so we'll just have it on one layer. And then have 3 nodes, we can create it, and then you can do whatever you want with these markers, and it will try its best to find a curve or blob of best fit. Oh wow. It's going well. Oh, hello, Cubic. So yeah, the stream delay is 42 seconds. So it's gonna take a while for me to react to anything you may or may not say in chat. But yeah, here we are. So that only took 180 generations. Something of this complexity would take probably 2,000 generations with the old software. But my objective for today is to make this even better, because right now we're using Darwinism. Right now, it's just randomly mutating everything. It's just randomly mutating a whole bunch of clones of the master brain, mutates it a whole bunch, and then figures out which one's the best, and then kills the rest, takes that one, clones it as the master, and then repeats. And yeah, Darwinism, humans didn't emerge from single cellular life in like half an hour, so we're asking a lot of this thing. But there is a better way. I'm going to try and implement 1 or 2 minute delay. I don't know. I timed it. It was 45 seconds, somewhere around there. Not sure, but we'll see. Should be good enough. It's not like I need to be super quick with any responses, but yeah, we're going to try I am going to try and implement gradient descent, which will hopefully make this go a little bit faster. Just out of curiosity, if any of you guys, or I guess there's only 2 people in chat now, hello, extra person, do you guys do anything to do with AI? Because my entire channel so far has been built off of scrap mechanic computers, and I'm assuming, computers, AI, there's similar categories. There's a little bit of overlap, but I'm assuming that you know at least a little bit. If not, I can go over the basic premise of it, but for now we'll just try and make this guy do something a bit more interesting. We can just do like that, and then it'll try its best to curve, but this might not work because I only gave it 1 layer with 3 nodes, and that's not a lot, so it gets stuck. So you can see the fitness gets stuck, and it's no longer it's moving. You can see the lines aren't moving, but the fitness is moving. That's because the fitness is measuring how close it is to making the correct decision, not necessarily whether or not it's making the correct decision. Because it's not just a Boolean, this is green, this is red, this is blue, this is purple. It has percentage weights on its decision as of which one it wants to choose. So we can use that to guide it in the correct direction. But yeah, this isn't going to go any further because I was thinking of doing it. I didn't do much besides random projects in Scratch. Oh yeah, Scratch. Oh boy. I have not touched Scratch since, I don't know, grade 8. My math teacher in grade 8, because we didn't have programming classes until grade 10, in grade 8, he gave us all a bunch of really crappy Chromebooks, and we started messing around with Scratch. And I guess that's sort of what half got me onto it. That and Hopscotch as well. Hopscotch is basically Scratch, but for mobile. That's what got me into programming. But Scratch, I heard that there's like some more sophisticated backends than just the drag and drop interface that I'm familiar with, but I prefer Java. Java isn't exactly the best for doing stuff like this. I am starting to learn C right now, but might not want to completely reprogram this thing in C, especially since it's not object-oriented, and that's all I know is object-oriented programming. So yeah, this is the code here. So we've got a main scene. We've got a main scene that can house the different the different types of scenes, or the different scenarios. So these two guys, then we launch it, and then that calls a nice little guy in the models right here, and then this is actually what houses all of that programming for the new decision space. And then we have legacy tab here, and then this is the legacy AI sandbox, and this has got all of its underlying classes within it, but we don't need to worry about that. Decision space uses quite a few more things. This guy uses not that. Quite a few different components. We have networks, layers, nodes. We have the basic network trainer. We have a bunch of input and output, training data, file manager, so I don't have to re-implement the files like the file management every single time I want to access a file. C++ instead of C. Yeah, I heard C++ is object-oriented, but I feel like it's a bit more of a challenge that I want to learn C, because my brain still can't comprehend functional programming, because oh, hey, hello, 0PSS. Yeah, 0PSS. Hello. Yeah, I might I'm probably going to move on to C++ after I learn C, but for now, I'd like to see how that actually works. Yeah, we just got a bunch of universal stuff for input, output, some stuff for the actual networks. So yeah, how familiar are you guys with neural networks? Because I'm just going to assume that you guys know mostly everything. Hello. Yeah, I'll try and explain things here and there, but yeah, so the basic algorithm. Okay, here's another thing. I haven't set up my debug perspective yet, and I will show this to you. I would prefer it if you were there. Okay. And if I run this in debug mode, over here we can see, over here we can see, no thanks, load, no, create new, sure, oh gosh, yeah, so I need to fix the issue of window resizing. I'm not exactly sure how to make that work right now, but if I put down a bunch of markers here and there, and then tell it to train, you can see over here all the threads popping in and out of existence. That's probably not efficient. So you can see there's 3 threads popping into existence here, but then beyond that there's another 6 or so. Oh, it's doing something. Yeah, so I need to make 2 things multi-threaded. Yeah, you think how they work, yeah, I'll try and explain as I go, if there's anything crazy complicated. But yeah, I have 2 main phases, the training and then the drawing phase. Turns out drawing takes the longest, because this is... Oh, hello. Nice, that worked. So this is all done on the CPU. I haven't done anything to do with GPUs because I don't know how to make that work in Java. I still need to figure that out. But right now, the CPU is doing this. So it needs to train the brain, and then once it's done with that, it needs to sample every single pixel here. Every single pixel. This is 512 by 512. It needs to sample every single pixel and get an evaluation, and then draw that out. So that takes a ridiculous amount of time. So I've split it up into 4 quadrants, and actually I'll show you my favorite bug. This is a wonderful, wonderful bug that I did not notice, because for actually evaluating, I use like, what is it? Like, I use variables that are in the instances of the classes. I don't like pass through data. It actually stores some of the in-between values in there. So if I tell it to do that, if I do just brain.evaluate, then you will see the horrible glitch of what happens when you try and do multiprocessing, or multi-threading, when you don't know how to do multi-threading. So, yeah. I've probably made a mistake making this multi-thread and not knowing how threads work, but yeah. This is what happens when you try and make 4 threads access the same variables at the same time. You get modern art, but deep fried. Oh my god. Yeah, I can do a lot with the CPU, but the problem is that I need to create a bunch of threads, and I would like to use the GPU because right now it is doing nothing. And that's a whole chunk of hardware that I am not using. So I want to try and make that work, potentially. But yeah, this is what happens when you don't know how multi-threading works. So yeah, I needed to make a clone of master every single time I wanted to evaluate so that it doesn't do that. Anyways, so this is training using Darwinism. It just copies, or it's got 5 threads, and then it uses the current thread to do the 6th thread. So there's 6 threads doing the training. It just copies the brain, takes the training data, and then it goes down to here. Depending on its thread, it's got a little slot where it can put in its best student, goes through however many students, and then once that's done, it takes the best one, kills the rest, copies that, and repeats, which is surprisingly fast for this, but this was basically a copy and paste from my grade 12 final project, which was, it was trying to classify handwritten digits. Best to say that didn't work because I used a genetic algorithm for something that has something like 10,000 variables to mess with, and that does not work with genetic algorithms because, oh my god, it takes like longer than the heat death of the universe to train. Like, seriously. Oh my god, it is slow. Yeah, but graphical bugs are nice, but fortunately I knew what was going wrong. Once this thing expands, I might not always know what's wrong, because it's harder to track down those bugs, but yeah. This was used on my old training, on my old project. I basically just copy-pasted the code and reformatted it a little bit, but the reason why it's super multi-threaded and has 6 threads doing it is because that took forever, because it had like 2 layers, each one with 20 nodes, and there was 724 input nodes or something for a 28 by 28, I'm doing that math wrong, but 28 by 28 input image. Oh, there were so many variables, so that's why I needed 6 threads, but now that they're much more simple, I probably don't need that. But anyways, I am going to try and make this not multi-thread. I'm going to try and make gradient descent, which I have a vague idea of how to do it. You just take every single variable and you nudge it a little bit and you see what that changes, and then you take that and you use that to determine how much to move it and in which direction. You do that for every single variable, and then boom, you get closer to the optimal value. This might be a little difficult. How do I refactor again? Refactor, rename. Here's the nice thing. Here's the nice thing about Eclipse. If you want to change like a variable name or something, you can just do refactor, and then you do that, and then this. Oh, right, okay. So yeah, it did change all of these things. Yeah, so genetic train, it just changed that name. But the problem is I have a superclass which requires it to have a method called train, which is not network evaluate neural mesh. Where was that? Why is it screaming? extends network, must implement training data, AI. Generic? Oh, genetic wait, what? Why did it change that? Oh, no, okay. Well, I'm just gonna pretend that didn't happen. That was a bad idea. How about we return refactor rename. Let's just change that back. Yeah, it's fine. I made a mistake. All right. Let's. How am I gonna do this? Literally stuck on making a new method. Okay, fine. Train descent. There we go. Wait, how loud is my keyboard? Because I struggle that with recording, and I guess streaming, you're gonna have to deal with that nightmare. Sorry about that. Okay, so we take, we want a clone of the master, right? Right. Master.clone, why are you screaming? From, oh, right, because clone doesn't. Casting. So much fun. Yeah, that's most of my process here. So yeah, disclaimer, I don't claim to be a genius programmer, and I never will be. So this might not go as fast as you might think it will, but let's see. Can I... Okay, let's go into this guy. What sort of things do I have? Get fitness, get layer count, get layer. Ooh, that's going to be useful. Okay, get layer. And then can I do... okay, yeah. For I equals 1, because I don't want to start on the input layer. You can... Yeah, I'm not sure how to do that right now. So, is it, like, horrible? Do I need to stop and fix that, or is it mildly acceptable? I is less than c dot get layer count. C plus. No. I plus plus. And then so we have what? Get layer index I dot actually no, that's all we need, and then yeah, so this is where it's gonna become super inefficient. It's fine, make 24-hour stream implement ingredient sent. Yeah. Oh god. It shouldn't be too horrible. I just need to make like 3 nested for loops, right? And then plus or minus track the delta change by the delta. Right? Maybe? Shouldn't be that hard. The keyboard is loud. Okay. Filters. No, that's not what I want. Properties. No. Advanced audio properties. No. How do I... How? Oh no. Wait, hang on. How do I... Oh my god, it's peaking by me. Or I guess it's almost peaking by me talking, but it's as loud as me talking. That is bad. Yeah, how do I... How? I'll keep coding until you until I get that message. But yeah, how do I add noise reduction? Please enlighten me. count. We do get node count? Yes, node count. There we go. Filters doesn't have any noise rejection. Oh, you need to add one. Okay, yeah. Filters. Add noise suppression, I'm assuming? Noise suppression, okay. Oh, now it's using 10% of my CPU. Well, does that make it better? Oh, okay, it completely turns off the microphone when I'm not talking. Okay, well, yeah, we'll see. Yeah, let me know if that's good. But hopefully that should work. Because yeah, if I spam my keyboard, I'm spamming my keyboard right now while I'm talking. It might come through because I can't really tell that. Actually, if I really spam it, it should be peaking, but it isn't. And if I stop and then type, absolutely nothing comes through. So this should be good. Hopefully. But now OBS is taking 10% of my CPU. Alright. Wonderful. Okay. J++, and yes, I am horrible with variable names. Sorry about that. And then, oh god, oh god. No, we need to... Double V for value. I don't know. I'm trying to keep these variables names small, but V is equal to... No, we need a node first. Okay. Node n is equal to get node index j. And then third for loop. Wonderful. J onto k then. Then n dot get weight count plus 1, because we also need the bias, and then k plus plus. Okay. So we need this should be I think that might be how that works. You get like a ridiculously... Do I have to... No, it's just that. We'll start off... Actually, we'll start off like... there. That should be fine. And then we do... It's equal to... Get count. Then we do the bias. N dot get bias, N dot set bias, and that is index. No, that is. Sorry. Get bias plus plus gradient delta. I just realized that we're going to need to evaluate this for every single thing of training data. Okay, so previous confidence, and then if confidence is equal to evaluate training data. No, it is training data, get data. Oh no. Okay, so we need to put this thing in another. No, we can just put it in, or we can put it in the for loop. Let's see. So for t, am I using t? No. Data t in data. This is getting messy. I will make it work and then I will revise it. Can only iterate over an array. Oh. Yeah. Do I really not have get all? Okay. Please stand by. Data array, get all data, return, what is it? Data dot to array, because that is an array list and not an array. And what are you complaining about? Cannot really? Oh, you suck. Oh, I remember. I barely remember how to do this. Dot for. No, is that not a thing? Oh, you suck. Okay, fine then. I'll do array list. It doesn't need to be an array. There you go. You happy? You happy? All right, back to this. Training data. Get all data. There we go. And here we are going to do t. Oh, I just realized that we also need the key. Why can't I use these fancy ones? T is less than train data dot get length t++, and then we need evaluate get data index t. Cannot convert from output data to double. Right, we need to do dot get yes, get, and then base data dot get key index t. Okay. Let me explain what this does. So yeah, we're iterating through every single thing of training data, and every single time we do that, we iterate through every single layer, then iterate through every single node, iterate through every single weight and or bias. We take the previous confidence, we get how confident it is right now with its current brain, and then we are going to do this. We're going to randomly mutate everything. Nope. And dot set weight, and then you require an int right here. This is going to be k. Dot get weight k. I'm sorry, but that doesn't exist. And get node int node get value, set value, get weight count, get weights. Well, why don't I just... No, okay, fine. Get weights, index k. There, happy? Yes. Okay. So yeah, and then we randomly mutate everything. And then we will do delta. Delta is equal to previous confidence. Why? Yeah, okay, I suck at spelling. Evaluate. Yes, we literally just do this again, but after the mutation. But this needs to be c.evaluate because we need to evaluate the clone. And then we subtract previous confidence. Okay, so then that's the delta. And so now we have the delta, and we want to, you know what, I will do that individually in each one of these so that we don't need to figure out whether or not it is node, weight, or bias. And then we do, here we need learn rates is equal to 0.1, we'll do that. Right. The delta needs to be divided by the delta. There we go. No, this is inefficient code, but it's me doing this programming. So delta divided by the gradient delta, and then we do this again, but it is plus the delta times the rate. There we go. In theory, this should be this done. Now I just need to test it. Okay, so let's go over what it does. So, you know what, how about we put comments? Comments are fun, right? For every training data, this, I just noticed this might be completely wrong, but we'll see. Every layer, node, and nodes. Parameter, yeah, efficiency, that's not gonna happen. This is what, hey, this is why we make it multi-threaded, so that we don't need to make it efficient, so that we can just, like, enslave our CPU for the rest of time. That is a bias, and then this is weights. Okay. I just noticed something. Yeah, so we should be doing this differently. We should be putting this within the for loop because we want each individual mutation to be compared against each and every thing. I don't know how to speak and think at the same time. For int t, I should have copied that. T is equal to r. No, t is equal to 0. T is less than training data. length. Turn data get live. Okay, thank you. And then t plus. Okay, and then we need to do. Yes. Then we need to do after this is done. This is done. Let's not forget our wonderful, wonderful curly braces. So after that is done, let's just copy this entire thing and get rid of everything else. Delete that. Delete that. Okay, Delta, where are you set? Why is Delta screaming? May not have been. Yeah, shut up. Oh god, I hate that. May not have been initialized. Okay. So. Okay. Yeah, hush. Delta. No. We need to do. Okay, yeah, remove this. This happens beforehand. Yes. Remove that, remove that, remove that, remove that. Then the for happens. And that doesn't need the if because that doesn't matter. We're just calculating the delta. This. Oh. How is this gonna work? Okay, so first we change delta. No, we need to do previous confidence. Okay, that's how this is gonna work. Previous confidence goes there. Then we get the delta. Right, okay. Okay, I know what's happening. Length plus. Okay, and then we do if no, that doesn't need to happen, does it? No. So previous confidence, we get the oh boy, brain is breaking. Okay, so we get the confidence. Previous confidence, really? Okay, is OBS picking that up? No, it isn't. Okay, because someone decided to mow their lawn. Okay, so previous confidence right now. Okay, yeah, we do need to do that for loop. Okay, previous confidence. So. So that's getting the confidence for every single correct answer. It may not have been. Okay, hush. It said. Shut up, it is initialized. So, we get the confidence for every single. No, every single answer. We look at the confidence of what the correct answer is. Then we do the mutation. Then we do that again. Yeah. I don't need to use this many variables, but I will. 0. New confidence. Okay, so the new confidence is now what we get, and then delta is equal to new confidence minus. Oh my god, I can't spell today. Yeah, the one thing that I prefer in VSC is that it tries to autocomplete your variables. If you try and do like methods, which I can't do, I'm just a double, but if I try and do, yeah, if I try and, okay, even that's not happy. If I do end dot, it'll try and autofill all the methods, but it won't try and autofill variables, which is a little bit annoying. Make some more change. Get the new confidence. Difference between previous confidence and new confidence. This might not actually... Okay, so if the delta is positive, that happens when the new confidence is bigger than the previous confidence, which means we're getting closer. So then we want to continue adding because we added the gradient delta. So we want to multiply the delta by the learn rate and add that. And if it's negative, which means that the new confidence is less... Thinking sounds, God, I need to think through this because it's going to be really hard to debug if it goes wrong. Yeah, if the new confidence is less than the previous confidence, that means it's going in the wrong way, which means the delta is going to be negative. And I just realized we need to divide by, no, we don't, it'll be fine. It should be fine. Yeah, delta will be negative if it's going in the wrong direction, then delta times learn rate will be negative, add a negative, it will subtract, so it'll go in the other way, it'll go in the direction that should be correct. And we do that for everything. And then I didn't actually need a clone because assuming this is a big assumption, assuming that it actually does work, this shouldn't ever, there's no reason to make a clone because this is only happening once. So I will get rid of, yes. Master, okay, master. Now, the way we could make this multi-threaded, shouldn't the difference be squared? Actually, that is a good idea. Thank you for reminding me of that. Because then bigger changes are more important. Oh, shoot, I almost caught that. Okay, previous confidence. Set that to 0. Then, okay, thank you. So that is actually a good thing that I caught that. We need to set it to 0, and then add the confidence. We don't set it to the confidence because then that's setting it to the last one. And then we need to, yes, we want to, wait, no. The thing with squaring that I remembered, you want to square the error, not the confidence. So you would want to do like a square root or something for this, but I don't know. We can leave it out for now. But the difference be squared though. if the delta is squared, then really massive changes. Then if it's not making a lot of progress, it's going to make it a small change, and if it is making a lot of progress, then it will amplify that change. We can modify that later. But for now, I think this should work. So we'll see what happens. So we'll go back. So first test, ladies and gentlemen, first test. Train descent. And technically this is gradient ascent because we are looking at the fitness and not the cost. But good enough. All right. Gradient test. We'll give it 1 and 3 just so that my CPU doesn't melt. And this is what our baseline is, about 16. So this actually, wait, no, this shouldn't overload the CPU because I haven't made it multi-threaded yet, but we'll see. Gradient test, let's see, can it learn at all? But let's try something like ridiculously easy. Oh shit. Oh no. Stop. Oh, right, okay, I need to manually update. That is the wrong thing. Hello. Yeah, I need to manually update the fitness and the generations. Okay, generations plus, and then fitness is equal to... Okay, yeah. Generations plus. Fitness is equal to... How did I get the fitness? It's down here that I did. Yeah, I'll worry about the fitness. I'll worry about that now. Fine. Okay. For t is equal to 0, t is less than data dot get length t plus plus, and we want this to be wait, do I do, is it master dot fitness that I do? Live training. Oh, yeah, live training is another fun thing that I might have to do. Yeah, okay, it is. That is set fitness to be total. Total 5 equals get length. Total plus equals training. So it is master dot evaluate training data dot get data index t, and then all of that dot get get index t. No, it is. Ooh. Right. Output data is output data out. Let's see. Out is equal to sort of evaluate. How do we do evaluate? New output data to get nodes. Output data. Oh, okay, right. Where is it? Why are you screaming then? Double. It should be outputting. It should be output data though, right? Oh, dot get. Yeah, no. Okay. Out. Dot. Format to hundreds, and then is equal to out dot get index t, get index training data dot get key t. There we go. That works, because then I need to, otherwise it'll just like floor it all up to the max. Paste. New confidence, there we go. Why is there an error? Where is the error? Where is it? There it is. Okay. Let's see. Yeah, it's just this again, but instead of total, or instead of yeah, it's just total. There we go. There you go. Okay, we good? We good. Let's try this again. You can close. Now I should actually be able to see you. I should probably delete all these boys. Delete back. Gradient test 2, we'll do 1 and 3 as always. Put a bunch of red up here, put a bunch of blue down here, and oh my! Wow! That? What is happening? What is it doing? What is it? Wow! Oh no! Oh shit! Hang on, wait, hang on. Yeah, it's a bit more than green. Oh god, can I just see for a second? Just give me 1 second, let me take a look at green test 2, brain. Oh. Okay, why? How? How's it going so fast, though? How is it physically possible for it to... Oh, I see. I think... Yeah, oh, okay, that makes a lot more sense. So, something is going wrong, then. I think. Well, clearly something's going wrong, but... Okay, diffusion space, so if it's not ready to copy, then it'll just loop through this a bajillion times. And if that's not enough of a workload, then it's not going to do anything. Okay. If I do, like, get layer, that is reference, right? Yeah, it is reference. And then get node. That should be reference as well. What is the gradient delta? Maybe it's... because the learn rate is too low? Let's try and bump that up an order of magnitude or two. Oh god, okay. Let's... Oh, hello. What is it doing? What are those ripples? What it... Eh? Oh dear god. Wait, I already have... Wait. Did I... Oh, wait. That didn't actually update, I don't think. Okay, launch. I think I might have launched the wrong one. Gradient test. Load. It's wibbly around the edges. Ugh! Ugh! What is that? What is that? Also, why does it say fitness is 2.8% if most of the stuff is in the red? Is it all just like 0 confidence or something? But it's normalized, so how... Huh? Okay, I know it's going wrong, but the way it's going wrong doesn't make sense. Which one? Okay, yeah, it's literally just... Oh god. Oh god, what is... Oh, hello. Okay, yeah, that happens every once in a while. It just complains that it can't load assets. Cubics, is my math wrong? Yes, it is beautiful. What is going wrong here? So for every single layer, except for the input layer, we take every single node, and for every single node, we check every single weight. Did I use, like, the wrong variable pointer somewhere? Okay, n.setWeight k should be the index of the node parameter, so that is correct. If k is equal to n, yes. That's correct. New confidence is equal to 0. Previous confidence. Oh, equals not plus equals stupid. Ah! I caught that bug and then I reintroduced it. Plus equals. There we go. That's what was... Okay, I won't say that's what was wrong. That was one of the things that was wrong. Gradient test. Maybe this time... Oh! Okay, is it even changing the... You know what? I'm just gonna... Okay. Launch, load, gradient test 2, delete. No, that's back, not delete. Gradient test 2, delete, back. Great new. Gradient test. And then 3 markers there, markers down there. Please, for the sake of my own sanity, what are you doing? What are you doing? Okay. Okay, you know what? I'm gonna slow this way the hell down, and I'm gonna do int pain is equal to 0. Pain plus and then system out print line pain. How many times is it going through this loop? Because it should not be going this fast. That is ridiculous. Load gradient test. Yes. Now start 25 times. 25? Really? Does that even make sense? How many properties? Test brain. Are there 25 of these? Yeah, okay, that makes sense. Okay, so it is going through. Is it? Okay, it's just adding. Some of them are negative. Some of them are negative. That was good. Is it being accelerated in the wrong direction or something? Okay, I'm curious, why is this fitness broken? Because this shouldn't be 4%. It should be a lot higher. Did I just mess up the fitness function? Master.evaluate training data, get t out format 100, and then total plus equals, thank you. I keep doing that. Okay, load, gradient test, load. Okay, well now the fitness is working, but nothing else is. Okay. Your plus equals, your plus equals. Yeah, plus equals for total. Got that. Just gonna look at every single equals sign and see should it be a plus equals. Okay, I think it's good. Okay. And let's see. So is it actually 25? What is that's a fitness? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Okay, so that is going through every single one. But why is it going through it? Weirdly. New confidence minus previous confidence. Out equals master.evaluate. Get that index, format to hundreds, and then previous confidence. Get index training data dot get key, so that only gets the correct one. Those guys should be correct. Maybe the gradient delta is too low. Maybe. Hang on, if I load it, does the artifacting go away? So I'm pretty sure that's only because it's going ridiculously fast. No, the artifacting is still there. Why is that happening, though? That shouldn't be possible. Okay, you know what? How about we print this delta times learn rate, because I need to see what order of magnitude is this. What order of magnitude are you telling it to shift by? Because if it's ridiculously small or ridiculously big, that's not good. Stop. Okay, so it's ridiculously small. How about we make this bigger? Tries to change by 0.1 each time. Let's see what this does. Launch, load, gradient test, load. Make it wider so I can actually see it. I really need to fix that. Okay, that's more like it. 0. Why are there so many zeros? Or is it just ridiculously ineffective? It just doesn't do anything. Oh boy. Where exactly is this going wrong? There's no pattern to which ones aren't doing anything. Well, maybe there is. That seems suspicious. block, nothing, block. 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 Okay, maybe it's just a coincidence, or maybe it's like genuinely doing nothing. I don't like that. I don't like that. It should be doing at least something. Delta, time to learn rate. What is delta? Delta, new confidence minus previous confidence. Why wouldn't it get anything? I have so many instances open. That's it. Is that? There are 5 nodes in this? That's the last 2. Ooh. The outputs are the only 2. So wait, if I were to add in gradient test, if I were to add in green and do a bunch of training with that. Okay, so the delta isn't. Huh. There is no delta if it's the one that's being evaluated for. Is there some reference error somewhere in here? I swear to God, if that's the problem. So the output node. The confidence does not change if the variable that's changed is on any node that directly correlates to an output. Now, why does that make sense? Why would that be happening? That's an interesting problem. And just to confirm, if we were to do some purple. Ah, no, it doesn't do anything. Oh, is it because the fitness gets stuck? Okay. So then absolutely nothing changes anything because it's getting... Oh, is it getting stuck in a pit? But it's still changing, though, right? Okay, stop, leave, launch, load, queue, load. Let's see these bottom numbers. Okay, top numbers. 21, 3, 21, 22. 21, 3, 21, and 22. 21, 3. Just that. 21, 3, 20, 24. Okay. Yeah. Let's see. Why are you working? Because there's obviously a difference that you could make if you tried to change something. Small change. Is it something to do with this? N dot set minus N dot get bias plus gradient delta. Then, if it was doing something, every single one of these would be getting gradient delta added to them every single step, which is 0.1. N dot set bias. If I, are these even? Yeah, it is. It is by reference. N dot set bias. Set bias. Bias is equal to bias. N dot get bias. Yeah. Gets the bias. Add gradient delta. I am not sure where this is going wrong. Get rid of... no, I'll leave this in for now. Delta times learn rate. Delta, if delta is 0, then it shouldn't be changing it at all, but the change from this gradient delta should have carried over. So if we just do like a stupid amount and run this. Stop it. Okay, so that... right, so it is changing it. Oh, I think I know what's going wrong. We need to subtract... okay. Delta, because we need to take that back out. Delta. I'll put it in brackets because I like brackets. But yeah, we need to take the gradient delta back out after we're done. So let's bring this back down to 0.1 and try and make a new brain. Let's see what happens. Launch, load, U, delete, back, create new. There. There, create. Oh! Whoa! Whoa! Okay, it took a bajillion generations, but it's going... Holy... Wait a minute, I said, make it like, okay, yeah, it gets bogged down because that was a very stupid thing to do, but add a bunch of blue here, add a core of blue there, put a red perimeter around there, keep your purple here, keep your green here, and start. Does it ever figure out how to... CPU, you okay? Oh, damn. I mean, it's not incredibly... Wait, is it because I didn't have enough layers? It works? Maybe? 3, 10. Invalid. Oh, I can't have a question mark. Okay. works maybe. Okay. Yep, up. And yep, up. And put some green in here and some purple in here. See what happens. I mean, it's taking longer. Okay, that was a horrible idea. %? Oh, okay. Oh, jeez. Okay, it's figured out red. Can it figure out blue? Do you know how to make blue work? Once it hits 50%, if it goes above blue, yeah, you can't, because it's making folders, and I guess folders don't like question marks in them. Can we get some blue? Hello. Ah, okay, now it switches over to... Uh-oh. Wait, hang on. Wait, what is it doing? Works maybe. Please don't tell me it's just using a giant amount of bias. Oh, please don't be using a shit ton of bias. Please don't be using a shit ton of bias. I mean, maybe it's just... yeah, that's why it doesn't like question marks then. Yeah, I mean, it sort of works. It works maybe. Let's go back and create new. How about 2? Just good enough. I hate having to name stuff. I hate naming things. Why did I make it require a name? Ooh, that's not good. Okay. Well, if we delete that, go back, create new, and we just do 1 layer. Okay, it is instantaneous when there's only 1 layer. But if there's 2 layers, or God forbid 3 layers, it just doesn't. Oh dear God, why is that happening? But I mean, look at this. It just wow. That works so well in very narrow situations. Can I even make that curve by that much? With... Oh yeah, I can. Okay, I don't know if it can go this far, though. Okay, it seems to have settled. Yeah. Every time I add a new dot, it goes really fast, which is interesting. But adding dots here does not do anything. I just... No? Okay, no? No? Uh-oh. Oh, yep, it broke. Okay, yeah, so if sometimes placing things... Index fit... I'm sorry, what? Yeah. Yeah, so this is an issue. Sometimes if I place it while it's at like a really specific point, it will break heavily. No, not there. training data. Yeah, so it broke because I added training data while it was also accessing the array, and it did not like that very much. Okay, can I make slider? If I add a slider to do, or maybe, huh? Hmm. Yeah, if I add a slider here, um, mm, SLD, what do I call this? SLD learn rate. And then here comes the fun part. We need to add it. Liquid lines visible. True, save. And now let's see, where can I put it? For now, let's just put it 0, 1, 2, 3, 4, 5. 5, and then 0, 1, 2, 3, 4, 5, 6, 7. 5 and 7. 7. 7. Okay. SLT. Let's do slider, and now how do I do this again? Okay, slider, it is min-max value. Yeah, I'm just gonna copy this, change the names, hope that works. Yeah, JavaFX is not the most efficient way of adding most of these things. And it is 5, 7, span 2, and 1. Alright, new slider, and we want it to be from 0.1, we'll do 1 to 10, and start it at 1. Yep, and set snap to ticks, true, tick marks, true. Okay, update main sliders. Update main sliders, and so we do the basic map we need. Okay. Set Learn right. And then there. So learn right, and then SLD. What is it? SLD. There we go. I won't be able to see what the learn rate is, but why did that not? Create, no. Main root. There we go. So this is the learn rate. Turn that way the hell down. Try and get it to switch. It refuses to do so. Huh. So that's the wrong thing. Data properties. Why do I keep closing this? Oh, it is very confident with some of these numbers. Which load you load? Because it's just stuck. Yeah, but if I were to make a new boot, okay, can't have that open then. Okay, create new 1 and 3. Wow. Try and make it spin. And it gets stuck. What if I added in just a tiny bit of random noise? Would that work? Yeah. I try and mutate it. Let's see what happens then. Wow. If I try and mutate it, then that gets it unstuck. Okay. Well, that took a long time to do. Come on. I believe in you. I believe in you. Okay, well, I can do it that easily. Ooh, okay. Not quite what I was going for, but Sure, you do you. Let's see if I try and do something a bit bigger. 2 layers. Can we do 2 layers? Can we do 2 layers, ladies and gentlemen? That is the big question. Does 2 layers work? Yeah, shaky is good for AI, surprisingly. If we do 2 layers, can this work? Oh! That's good. Oh, that's good. That's good. This should be able to do this. Oh! I think we might be there. This is not. Oh no, this is not at all how this should work. Yeah, that we should not be mutating it, but mutating it works. Okay, let's see what happens if we try and make a smiley face. Purple. Like just a really loose smiley face. Can I do this? Because I had to, like, really fight for this to work with the random mutation. Wait. Down. Hello. Oh. Bit of blue came in. Huh. Oh, some red. Oh, some more red. Come on. Come on, bud. I believe in you. Okay, I no longer believe in you. Then let's delete that. What should I try and make? What should I try and make? Well, let's give it everything. Let's make a dome, and let's see if we can just do that. Why is it stuck there? Is it because I'm asking too much of it, or is it because my algorithm is broken? That is a very important distinction that must be made. Why is it not working? I mean, it is... No, it's not really going up. You know what? I think I do... Green dot set max mutation. So then I can bump up the aggressiveness of mutations. Just go like crazy. There we go. Bring in the power of Chernobyl. Yes! Oh, I can't believe that works. The power of Chernobyl. Wow. The power of Chernobyl. Damn. Making the mutations crazy strong really does something. Okay, how about we try and do something else? Oh, God. Yeah. I put caps lock on. Yes, I did. Okay. Let's see if the smiley face works now. I'll try and make it like really big eyes so that it has a really good chance of doing something. Yes, more purple. And then... Oh, God. Oh, this guy's seen some stuff. No, no, no. Ah, okay, you know what? If I perfectly match it up, it'll be fine. Alright. Begin. Mutate. Ooh, we got some red. Turn the mutation down a bit. Yeah, it gets stuck, and if you just hit it hard enough, it'll, yeah. It'll work. It'll work. And more mutation. Give it more. The red is creeping in. I think this might still be... Oh! It was so close! Oh! You know what? I'm going to turn this mutation thingy, it's not technically not learn rate. Major tick unit. Okay, you know what? Let's do 0.1, and this goes from 0.1 to 1, and it starts at 0.1. There we go. Now, let's do goes to 0. There we go. So we can turn it off if we want. This. Oh. Give me some mutation. Give me some radiation, baby. Come on. Oh! Alright, now figure it out. Figure it out. Come on. You're so close. Figure it out. Figure it out! I believe in you! Oh! Why? It's so close. Come on. Bring it back. Please. If I ask nicely, will you bring back the eye? Hello? Hello? Please? Yeah, it was so close. I'm sad. Maybe it's just too much. Yeah, Cubics, what should I draw? What should I make using this? Oh, hello, new person. Oh dear God. I'm not gonna butcher that. Hi. Sorry. Sorry about me not being able to pronounce your name, but hello. Um, if you're just catching us now, we have partially implemented gradient descent. It's a bit stupid, but if I just get a really simple... Actually, no, I'm pretty sure it just works if I don't give it too complex of problem. I put a bunch of red up here, and then a layer of blue, and then a horseshoe of green, and then some purple in here, and some purple up here. This should be able to work. Maybe. I'll turn up the mutation rate. Please. Wait, hang on. What did I set the default learn rate to? What is default learn rate? Ah, that's probably why. That needs to go down a bit. Draw a gear. Ooh. That might be extremely difficult for this thing to do, but if it's only 2 colors, let me just try and get this to work. Mutation. Go. Come on, man. You're doing so well before. Oh. 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 It's fluctuating. Please. Please? Okay, fine. I'll get red here and blue here. Go. Oh, it's like, it doesn't at all. Oh, but it's going up. Oh! Please. Please. Unknown person in Polish. Okay. I never would have guessed that. Sorry about that. Oh, God. Yeah, do you know what we're trying to do here? I haven't seen you on the Discord or anything, so I'm not sure if you're entirely familiar with what's going on here. Oh, and I see there's a third person in chat. Hello. I don't know. You haven't said anything, but I see it says there's 3 people watching. Yeah, I just got it. I just got it to kind of half work, but it's being really stubborn now. Oh, no. No, it's gonna work. It's gonna work. It's gonna work. There we go. All right. Yeah. Oh, dear God. All right, let's try and give it something a bit more simple. Let's delete that. No, come on. Delete. Get back. No, wait, I can't use periods. I don't know if I can use commas. Can I use a comma? Yes, I can. Okay. So let's try. What color do you want the gear to be, Cubics? 2 last month. It was very fun to try. Ah, yes. So, oh, there's 4 people now. So yeah, last thing that I got to work was a genetic algorithm. You know, the whole Darwinism thing, that didn't really work out too well, so now I'm trying to get gradient descent to work. Yeah, usually it either works or it doesn't, and there's no happy in between. What were you trying to do? Were you trying to do like a simple decision boundary or something? Because decision boundaries, even that, here, this is I made this in grade 11 as my RST, and this, oh god, it is extremely dumb. Even if you try and get it to like the simplest thing like this, it takes forever. I tell it to train a bunch. Oh, Vidgot, hello. Green. Okay, so you want the gear to be green, but what do you want the background to be? Yeah, you can see, it's stupid. The newer version can do this a lot better. Yes, hello, Vidgot. Yeah, the newer version can do this a lot better, but this is horrible. To see somebody try and maybe I'll learn something. Yes. I mean, I'm not the best teacher so far. Oh, that's why this isn't working right now. Let's put some dots right there. Yeah, I don't know how much I can teach you, but yeah, what kind of algorithm were you trying to implement? Because if it was just genetic, there's a lot of lessons that I've learned here that I can teach you, which should hopefully make it go a lot better. But yeah, that thing sucks. But this new thing now has gradient descent. Uh, kind of made. Okay. Oh hey, green. Okay, so green with a red background. You got it. So I'll just get the circle first. Let's see what that can do. Yeah, so that's what I was doing. That's what is it? The Darwinism algorithm, genetic algorithms. So the best way to make that work better, the way that I made this work a lot faster, is if you try and evaluate how close it is to getting the correct answer, not just necessarily is it correct or is it wrong, but how close it is to getting the correct answer, then use that. Because, if it has a long ways to go and it needs multiple mutations, the chances of it getting all those successive mutations in a row is pretty low. But if you tell it that it's going in the correct direction and the fitness, it's getting closer to making the correct decision, even though it isn't correct yet, that'll point it in the right direction. If it tries to go the other way, it won't work. Whereas if you don't tell it, then it'll just be randomly stumbling in the dark until it hits the correct answer. So that's going through a lot of generations. Oh, come on. No, I want purple. Purple, not green. Come on. Come on. Oh, there's purple. Here we go. Come on. I believe in you. I believe in you. 70. No. It's getting stuck. It can't do a simple circle. Oh, dear God. Oh. Oh. Very small amount of mutation. How about no mutation? Does that do anything? No, it gets stuck. No. Hello? Okay. Alright, unfortunate news, guys. I think it might have been a fluke. I think it might have been a fluke that this thing actually worked. Yeah, 6,000 generations and it can't get a circle. That's not a good sign. Out of curiosity, I'm going to re-enable the old algorithm and just do normal training and see what happens, because something tells me this is going to go really quickly. Just ask it to go. Can I crank up the mutation rate? Yeah. So that's the old algorithm. Oh, I can make it do nothing if I just turn that down. Huh. Right, because I can control the mutation rate here. Okay, so... Oh, dear God, what does this mean? Oh, what does this mean? What does this mean? Why? Randomly stumbling is now better than figuring out correct direction. I am a bit confused as to how this is going so poorly. And now this is stuck. Okay, so if I stop this and then change it to the new algorithm, give it a little bit of mutation, then... Oh, light speed. Light speed! But it's not really working. Is there something else creeping up in there? Am I still printing? Yes, I'm still... What am I even printing? Maybe that's one of the issues. Well, no, that's not going to be one of the issues. That's just going to be slowing it down, which I don't think slowing it down is that big of a downside at this point. Yeah, debugging at its finest. Just Get all of the print statements. Just every single print statement. Get it and put it in. See what happens. Start again, please. Well, now it's not. Oh no, it is still printing. Whoa! 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 Oh god! Oh dear god, are you okay? Why isn't it... Ugh. Okay, close it off. I've made a smiley face before. Why can't it just... Ugh. On the bright side, it's going through like 300 generations a second. Oh, God. Okay. Yeah, it is very much having a seizure. Alright, you know what? I'll go over the algorithm again, because now Vidgut and Unknown Person is here. I'll show you what the heck is going on with this thing. So right now, it goes through every single layer in the network. And in every single layer, it goes through every single node. And through every single node, it goes through every single... Yeah, parabola had a stroke. God. It goes through every single parameter with the node, so every single weight and the bias. It increments this pain counter, which I should probably remove now, because that was just seeing if it was actually working. Yes, pain. I'm a professional. So it goes through every single parameter. It gets the previous confidence of every single correct answer. So it evaluates every single thing in the training data. It gets its confidence of what the correct answer is supposed to be, and that stores it in previous confidence. Then after that, it goes through it goes to the node. It goes to the parameter that it's currently working on. It adds in gradient delta, so it changes that node a little bit, and then it reevaluates everything, gets the new confidence, and then the delta is the new confidence minus the previous confidence. And so if the delta is positive, then we want to keep going in that direction. So we will, first of all, we take out the gradient delta, so it's like we didn't do anything. We do the delta multiplied by the learn rate, and we add that to the bias. So if it's positive, it'll keep going positive. If it's negative, which means that the new confidence is less than previous confidence, so it's going in the wrong direction, then delta will be negative, so then it'll subtract from whatever the thing is, and it'll go the opposite direction because the opposite direction was the best way to go. In theory, that should work, right? But it's getting stuck. Like, a lot. A lot. It's getting stuck. Right, and then at the end, we just add to the generations, which, oh my god, this goes by fast. Wait, we are doing this after... Yeah, we are doing it after the 4. So it adds the generation, and then it calculates the fitness, and then sets the fitness. But it's not working as it should. Any ideas as to why it isn't? Any takers? Because I've been at this for an hour and a half now. Reminder to stay hydrated. Get some water. Let's see why. So are we back onto, yeah, train descent. Launch, create new. Simple. I'll do 1 and 3 and create. Put a red dot there, blue dot there, purple dot there, and a green dot there, and tell it to start. And it. Oh my. Oh no! Oh, that was all because of the random mutation. Wait, so why is it now super slow in comparison? Alright, we're at 58,000 generations and it hasn't done anything. Something might be wrong. Simple brain. Are the deltas just ridiculously low? I'm curious as to what is happening here. I've never seen this before. Turn that off. Okay, what are the deltas? Oh, E minus 6. That's probably why. Yeah, so let's do... But why would it be so damn low? It's not supposed to be that ridiculously low, is it? How about we do previous confidence divided by data.length. That way it isn't affected. Oh, that might be why if you have a lot of data points, then the confidence is going to be bigger, which means the delta is going to be bigger. So because I'm not... Yeah, so if I added in a lot of data points, then that would change the size of the deltas. Okay, that makes a bit more sense. So this is making it more consistent. Y equals data length. Yeah. Okay, that'll make it more consistent, but that means it'll be ridiculously slow no matter what. We also want to... let's just see what this does. It'll probably make it even worse. Launch load, simple load. Yeah. Oh. Ooh. Turn up the mutations, then it just goes crazy. And somehow it's going through 1,000 generations every second. Still don't understand how this delta can be so damn low. What is... Okay, let's just say that that's because that brain is dead. And we will make a new one with less extreme values for all the nodes and such. Purple, no mutations. Whoa. If that happened faster. What are the deltas then? I can't see them because they're so far back in the history. So then what if I do that? Okay. Okay, so for debug purposes, I will tell it to stop if the fitness is above. And if get fitness is above 0.9, 0.9, trans is equal to false. Wait, hang on. No, I will do one better. Wait, no, I can't really do that though. Yeah, did something. Where's the stop start button? Start start. How does this work? Okay, that won't be happy. Yeah, that'll scream. So I just need to. Okay. Yeah, no, this should still work. Okay, so just so that I can see what those deltas are. Okay. Simple 3. And do it, do it, and do it, and do it, and no mutation, and go. Okay, I'm gonna assume that's a rendering error. Right, and then we'll do. Yeah, that should be a rendering error. Go up. Oh, okay, so it's slightly less tiny. Those are ridiculously tiny, but then once it finds its path, then it continues on. Okay. And yeah, so if I go out, launch, load, you load, then it's actually correct because it went so fast. Oh, hello, 0PSS. You're back. Welcome back. So yeah, a lot of things have changed since you've been here. Wait, were you even here when we were... I don't know. It's been a while since you've been here. Hello. Yeah, it's doing weird things now. I check how crazy is that? Not really all too crazy. So I want to be able to get it to go ridiculously quickly. Launch, load, simple, load. Yeah, okay, so those are rendering errors. Yes. I want it to go quickly, but I don't want to have the training rate set so darn high, but that's sort of the only way to do it because yeah, learn rate is at 100 already. If I do 1,000, then what did I say? What did I do? Oh, I did that. Okay. Launch, load, you, delete. Sorry, we'll get back to the gear later. That I didn't. Okay. Simple, let's try this again. And adding in more dots didn't do anything because I fixed that. We start. Wow. Okay, 10 generations to do that. That is pretty good. Okay, it was 19. That's sort of off, but still, it is much better now. So let's stop this then. Let's remove these print statements and let's try and go for it, even though I haven't actually really changed anything. Let's try and make something more complicated. All right, back to the gear. Let's see. No, load, you, delete, back, create, gear. 1, no, let's do 2. Actually, no. I need to test and see if I make something like this, how quickly does it learn? Oh. Phone freaked out and tried to make a clip. Ooh, okay, that is It's going pretty well. The stream isn't broken, is it? No? Is it still working? Yeah, okay, I think... Yeah, it's still working. I don't know, my phone just suddenly decided, hey, let's make a clip! I don't know. Okay, and that's where it breaks down. But wait, that's with mutations. No, that's not the furthest that you can go. You can go further. Come on. Mutate. You can curve more than that. I've seen you curve more than that. Stop lying to me. Okay, what does this look like? What does the brain look like? Honestly, the values aren't too extreme. Not sure, not sure why it is not working. Because if I did, okay, let's kill this, minimize, kill. Because if I just did normal training and then tried to launch this, turn the mutation rate up. 94.5, really? It should be. Oh yeah, there we go. So it is possible to do that. It is possible to curve it like that with this size of network, so why isn't the gradient descent doing that? Why is it... Oh, dear God. Gradient descent. What is your problem? Should I emphasize bigger differences? Should I square the delta but preserve the sign? No, I mean, if there was a bigger delta, then it would move faster, but the issue is that it's getting stuck. The issue isn't that it is not moving fast enough, the issue is that it's getting stuck in a false bottom, which, how does one fix that? How do you make it not get stuck in a false bottom? The way that we're trying to do it is to make it mutate. But that doesn't really sound like that good of an idea. This mutation is not reliable. Whoa. You good, pal? Whoa. What is this thing doing? Why is it spazzing out so much? Was it overshooting? Oh, it might be overshooting. But only in this case. Only overshooting here, but other times it's getting stuck in a false bottom. I don't know how to fix this right now. The problem is it's getting stuck in a place where no matter which way it moves it, it won't get any better. Which means it'll get stuck. And then the other issue is that if it knows exactly where it wants to go, it'll move there too fast, and it'll overshoot and go the wrong way, which will sort of help with getting stuck in a false bottom if it doesn't get stuck there in the first place. Come on, stop fighting me. I know you want to. I know you want. I know you. I know you want it. You want it. You did it for a second there. Come on. Stop fighting me. Just do it. Just do the thing. Come on. Now, how did it... Oh, dear God, what is... right now? And so this is a network with 2 layers. So it's a little bit more complicated. Any ideas from one person who's still in chat? Wherever you are, thank you for staying. But, yeah, any ideas? I'm gonna have to rewatch Sebastian Legge's video. Yeah, most of this is general memories of what Sebastian Legge has showed me. So, yeah. Not exactly sure what I'm doing here. I'd like to look at some graphs here. Oh, how wonderful. Look, there's 5 people watching at one time. Oh my god. That's crazy. Right. What are we doing? What are we doing? What are we doing? How do we solve the issues? We could make it only sample a random amount of the sample size of training data. Selector, yes, I know it's not used yet. K is equal to 0, K is less than, So, int array selectors is, okay, so then it's equal to int array data length get length, yeah, get length times, we'll do 0.5 for now, and pass this to an int. I said pass this to an int. Here we go. And then for int then we would L to L no L, so we'll do M which is 0, M is less than plus, so we're just gonna get some random. Do that here. Okay. Okay, so then we want to do int index m is equal to math.random yes times data dot get length, and then we want to do so yeah, we'll do +1 because rounding this would work. So math.random goes from 0 to 0.9999. So if we just round it, that will work. But it needs to be length minus 1. Length minus 1. And add another guy right there. And then we do round. Did I add in too many? Did I add in too many? Come on. Oh, what am I doing? Selectors index m. Cannot convert from long. Yeah, why are you a long? Make it an int. There we go. Okay, and then t is less than wait, we could do for int t in selectors. There we go. Haha, I finally get to use that fancy for statement. Int t selectors. There we go. So now it's only going to use half of the training set each time. So that should hopefully let it settle a bit more randomly. Why is there another one here? Okay, launch, load, load. No mutation. Okay, how about a bunch of mutation? And then no mutation? Okay, it just settles. How about we try and do 25%? And then we need to do, this is selectors.length. No. It's primitive. Not length, there we go. Save, and then no mutation. Oh, that did something. Oh, I see what's happening. There we go, but that shouldn't have. Oh, because oh yeah, because it screwed up the. Okay, yeah, that makes sense. No mutation, that might backfire horribly. Why is the amount of generation speeding up? That doesn't make any sense. Right, and I need to do selector stop length. No, huh? I think I just massively screwed up this brain and I need a new one. Let's see what happens. Okay, let's go back down to 3. Because if I made it worse, then that's not good. Okay, it should be able to do this in like 30 generations or something. No mutation. Okay, it can still work. Okay, it is. Why? Why aren't you doing what I want you to do? Oh my god. And now it's just green. 47,000 generations, and it hasn't learned anything. Okay, what is going on? Okay, how about we turn the learn rate down, because maybe it's overshooting to get to that new thingy. Error loading. Huh? Okay. Nope, that thing is dead. Okay, let's try to get caps lock off, please. No mutation. Somehow it's getting stuck. Alright, thank you, unknown person. Or, it was, yeah, unknown person. Alright, yeah, thanks. See ya. Oh, God. Oh, it has been 2.5 hours, okay. Crap. Oh my god, why is this thing not working? Oh my god, please work. It just gets stuck 50%. I don't like that. I don't like that. I don't like that. Train descent selectors is equal to new int array with the length times 25. Every single thing in selectors is equal to int math.round math.random training data.get length minus 1. That should be random. Oh no. Why is this not? Why is this not happy? Can I just do launch load? Let's do brain dead. 0. We have nothing. Red marker, blue marker. Maybe a few more because I don't know how the length works, but does this work? Okay, that works. Does this work? Where's my purple? There's my purple. What is that, 164,000 generations? Okay. I just do 1 red, 1 blue, 1 green, 1 purple. Tell it to start. It does do that. If I tell it to try and mutate every time. Epilepsy warning for those of you who are sensitive to that. And then it just calms down. Okay, 1,000,000 generations. Why is this thing not happy? Okay, let's do... You know what? I'm gonna take off that stupid grid lines. That is annoying. No, went too far. There it is. Let's save that. Launch, create. That's brain dead. 1, 3. 1 red marker, 1 blue marker. Does this work? Okay. 2 of each. Really? Why is... I am very confused as to what. Four and 4. That works. Okay, you know what? I'm just gonna make this a bit less crazy. So at most it can only do, what, 100 every second? Okay, that's better. There it goes. Oh, no, 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 no. Now, why did that lag out? Oh, no, that's not an issue. Yeah, no, when it's lagging out, it's because the queuing is not working. But why is this now? What does the brain look like? This brain dead brain. Oh! Oh! Hello, that is a new issue. Somehow... Uh... Fitness is not a number. Okay, how about we return to main menu and then we try and just replace all of these with 0. No. Okay. Yeah, replace with 0, please. Replace all. Save, close, launch, load. Not brain dead. Load. Go. No mutation. Go. Why? Why? How is it this stupid? Is it just eventually gonna get there? Yeah. Yeah, there it goes. Oh. Believe it or not, you have to be smart to make AI work. I don't think I'm quite there yet. Okay. Okay, how about we take out... Okay, selectors, and then just... It's equal to M, so this thing doesn't... So I don't need to completely rewrite it, but if we were to... Mutation. Oh. Okay. Well, that was interesting. Hello, Tachi. Sorry, I am not good at pronouncing people's names. Tadashi Siwa? I'm sorry. Hello. Welcome to me slowly losing my sanity over artificial intelligence. Why? If I try and do that again, does it do the same thing? Does it just slowly slide in casually? Bunch of red, bunch of blue, bunch of green, bunch of purple. Make magic happen. Is it going to do the exact same thing? Is it just going to... Hey there, pal. Here's some color for you. Yeah, it does do the same thing. No, this would be Java, and on top of that, really old Java. It is, JDK 8, and we're on 18 right now, and, it is, this is Java FX, and the reason why it's Java 8 is because that's the last, I think, the last version that, Java FX, which is like this visualizer thingy, is actually packaged within the development kit. Oh no. And so what happens if I tell it to start and I just give it a few mutations? Then it freaks out because the mutations overpower the gradient descent. If I tell it to stop and then continue, then it slowly morphs its way back. Okay, so now I go in here and turn the learning rate back up. Does it work? Did I just see an error? I don't. Launch, load. Right. Actually, no. I will check that first. If I turn the mutation way up, then start, then it does hold its ground a little bit better. Return to main menu, launch, load, you delete, back, create new, 1, 3, put a bunch there, and a bunch there, and a bunch there, and a bunch there. No mutation, no mutation. Let's start. I mean, it's faster. Okay. Now, if I try and do 2 layers, each one with 3 nodes, maybe. If I try and do this, oh, no one's here. That's unfortunate. Oh well. Bunch of red up here. Bunch of blue. Bunch of green. And a bunch of purple. No mutation. Start. Does it slowly slide in? Ooh. Okay, that can move quickly. It's the bending that doesn't want to work. And as I say that, it starts bending. What is the problem here? Can we just move this blue over and then try and bend it? Why is the fitness going down? I don't even have any. Okay, let's try and add some mutation. It's not happy. Okay, that's 95% fit, or 91.5% fitness. Okay. Not exactly sure how to fix this. Ugh. All right. Just stop. Just we'll deal with it later. We'll fix this later. We'll fix this another day. I think this is about enough for now. And my brain is fried enough. So I think I will sleep. Yes. I'm done then. Alright. Back to the endless void of OBS. Hello. Yes. Alright. Well, people came and people went. There is supposed to be someone here right now. Because my phone counts as one concurrent viewer, but if I leave that, then there should be only one person remaining, right? I just unplugged my microphone instead of my phone charger. Oops. Yeah, okay. Well, there is one person left. Hello. And goodbye, I guess. I think I'm just about done with this stream. Not a train wreck. There were a decent amount of people here every once in a while.